Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes? Warm-up 76 is on the screen. Now, I left you a video lesson on Monday that had a warm-up that looked something like that. I'm going to go over it once more myself just to make sure we got it. But you should be able to do numbers 1, 2, and 3 completely by yourself, and I'll walk you through number 4. Okay? So, I'll give you guys some time. Copy and go. All right, here we go. Get this show on the road. For the sake of time, let's go with number 1. Find the sum. So, if we add this plus this, oh, it's frozen. Let it go. Let it go. There you go. If we add this plus this, here we go. Start with the constants. What is 1 plus 3? 4. And what is 5i and negative 4i? 1i. Hands if you got that. All right. Difference. We're switching now to subtraction. Subtraction. So what do we do with subtraction? You need to distribute here and here. Is that correct? So therefore, negative 3 and positive 4i. So combine. That leaves us with negative 2 and positive 9i. Hands if you got that. All right. Next, product, which means we're going to multiply. So let me make some space here. Here we go. What is 1 times 3? 3. 1 times negative 4i. Negative 4i. 5i times 3, that's positive 15i. And 5i times negative 4i, that's negative 20i squared. Can we pause the music really quick? All right. Combine like terms. Yes, Mr. Q, these two right here. So that's 3 plus 11i minus 20i squared. Am I done? No, remind your neighbor what do we do there? Let me zoom in case you don't see it. What do we do here? All right, good communication. Caesar, what do we do? Edwin, what do we do? All right, don't tell me you guys forgot. I'm going to send Ulisa to slap people around, my goodness. Sean. Yeah, substitute a negative 1 for the I squared. Negative 1 for the I squared. Therefore, we got 3 plus 11i. Negative 20 times negative 1, that's positive 20. Therefore, combine these, 23. Michael Jordan. And then at the end, 11i. Hands if you got that by yourself. All right, some of you forgot. What? It's only been a weekend, my goodness. What? Come on now. All right. Let's go to number 2. Number 2. Here it goes. I'm going to solve by completing the square. Let me make some space here. All right, remind your neighbor the first step for completing the square. First step. All right. First step, Annette, first step. Set it equal to 0, so x squared minus 4x minus 6 equal to 0. Next, Abby, what do I do? Divide by 1, so we end up with x squared minus 4x minus 6 equal to 0. Continue, Elijah. Add 6 to both sides. X squared minus 4x, empty space equals 6. Continue, Joseph. Negative 4 divided by 2 squared. Yes, to both sides. Negative 4 divided by 2 squared, so that is x squared minus 4x plus 4 equals to 6 plus 4. Is that correct? Negative 2, yeah. This becomes a 10. So we got x squared minus 4x plus 4. Next step, I factor. So square root of this, square root of this. So that is x. That is 2. Sign of the middle. And I'm just going to go straight to the square. All right? Help me out from there. Enrique, what do I do next? Bless you. Gabriel, help him out. Square root, both sides, x minus 2 equals plus minus square root of 10. Yes? And then we solve for x, so that means I add 2, x equals 2 plus minus square root of 10. And then from there we just write our two equations, 2 plus square root of 10, 2 minus square root of 10. X of 1, x of 2. Hands, have you got that by yourself, some of you? Yeah? All right. All right. Let's go to number 3. Man, it's taking us a while to go over these. Number 3, I'm bringing back transformations. You're like, oh, snap. Yep, they're coming back, guys. Make sure you know how to do these. So here we go. It says graph f of x equals x squared without a table. What? All right. X, f of x. So, look up to the screen. Tell your neighbor the 5 points that I need for that function without a table. What are those points? All right, looks like Jesus got this. All right, Jesus, give us the 5 points. Start at 0, 0. Up 1, 1 to the right, so that's 1, 1. And then up 2. Up 3 and 1 to the right. All right, so it's 0, 1, 1, 2, 4, and then same on the other side. That is correct. All right, so we got f of x. So now we need g of x. So that means we need to substitute these values in for our form, yes? So what is a? A is 1, so that goes there. What is b? 1, so we get 1 over 1 there. What is h? H is 5. And what is k? Negative 7. So let's see how that looks. G of x equals a1 times f, parentheses, 1 over 1x, minus 5, minus 7, and since this is a squared, so I put the little square there. So g of x equals, do we need the 1 anymore? No. So I'll just write, and I'm not going to use the f anymore. I'm going to start with the parentheses. 1 over 1 is 1, so that leaves me with x minus 5 squared minus 7. So, tell your neighbor where we're going to move those 5 to. Then Renzo is going to enlighten us where we're going to move these 5 points to according to that. Where we're going to move those 5 to. 5 to the right? 7 down. That is correct. 5 to the right. 1, 2, 3, 4, 5. And then we got 1, 2, 3, 4, 5, 6, 7. So the vertex is there. Then I got 1 here, and then 2 and 4, 2 and 4. and that is our g of x. Is it coming back? Yes? Kind of, sort of? Yeah. All right. And let's go to our last one, number 4. Number 4 says, solve the system using substitution. Here we go. So, they give us y equals 2x plus 3 and y equals x minus 2. So here's what substitution means. This one says that y is equal to what? All of this. Is that correct? So, for the second equation, instead of writing y, what am I going to write? 2x plus 3. That's why it's called substitution. I'm going to substitute on the second one instead of y that. So I'm going to write 2x plus 3 equals to x minus 2. Then I solve. Here we go. I need all x's to one side, so I subtract x to both sides. That leaves us with x plus 3 equals negative 2, minus 3 minus 3, x equals negative 5. All right, so whenever you have a system with two variables, we're going to end up with a coordinate. So in this case, we already have the x, which is negative 5. So now we need a what? A y. So you substitute this value into one of the two equations. Which equation do you want to use, the top one or the bottom one? Some of you said top one. You can use either one. So I'm going to use the bottom one. So I'm going to bring this one over here, and I'm going to write y equals blank minus 2, but I'm going to substitute negative 5 in the blank for the x. So y is equal to negative 7. And this is my solution. Now, what does that mean, Mr. Q? That means, look up please, that means that if I was to ask you, pay attention to this part, to graph these two, guess what's going to happen? They're going to what? Intersect at that point. That's the solution to the system, where both graphs intersect. Okay? Whew, that was a lot for a Wednesday, right? Let's go. All right, copy the agenda, please. Warm-up 76 is done. Today we're moving on to complex numbers. And bring it, Mr. Q. Oh, yeah, I'm bringing it. Tonight's home play, complex numbers, play sheet numbers 1 through 18 only. Only. There could have been more, right? Let's go. Okay, we good? All right. By the way, did you have home play over the weekend? Copy the code to access the home play, NSX8H. NSX8H. So anyways, bring it tomorrow, your signed screenshots that you should have brought, right? Due tomorrow, giving you an extra day. All right? So, with that said, tonight's home play looks like this. Oh yeah, we got this. Let's go. Let me say that again. Let's go. All right, you get a coordinate ready, please. I can define and compute complex numbers. I can define and compute complex numbers. You do need a Frayer model because we're moving on today. Copy and go. All right, here we go. I can define and compute complex numbers. So we started with complex numbers at the beginning of the school year. I gave you guys a little roadmap where we were headed for this school year. We did real numbers, we did imaginary, we did complex. You're like, I don't remember, Ms. Q. Well, we're going to remember today. So, What are complex numbers? Write this in, please. Complex numbers are numbers that contain one real number and one imaginary number. Complex numbers are numbers that contain one real number and one imaginary number. Complex numbers are numbers that contain one real number and one imaginary number. Complex numbers are numbers that contain one real number and one imaginary number. So can you picture that? One real number and one imaginary number? Picture it. You got it? Locked in? This is what it looks like. Let's see. 5 plus 3i, 12 minus 6i, and 2i, and square root of negative 8. Square root of negative 8. All those are complex numbers. Now, just to double check, it said numbers that contain one real number, one imaginary number. All right, so let's see. Real number. The 5 is a real number, yes? Okay. And for that one, does everybody see the imaginary number? Yes? How about this one? Which one's the real? 12. And what is the imaginary? Negative 6i. How about this one? What is the real? Everyone? Yes, 0. That means this is the imaginary. So far so good, yes? This one, we can rewrite it at square root of 8 times square root of negative 1. Yes? Which means what? What is this, everyone? Imaginary. And this, I'll leave it as square root of 8. So that means my real number is 0. Now we're going to get to these where I ask you for decimal values for those, but for right now we're good, right? All right, so those are complex numbers. All right, students, complex students. Non-examples, copy these. 23, Michael Jordan. X squared plus 3x plus 2. Negative 3 plus x equals 10. So as you're writing those down, tell your neighbor why these are not complex numbers. Why are these not complex numbers? Tell your neighbor, please. So if we were to be asked the question, why are all of these not complex numbers, and you were going to win $1 million, you would say what, Joseph, for $1 million? There is no imaginary number to any of them. And of course, the last one is an equation, therefore it's not a number. It's an equation, okay? Hashtag, write these down. It has to be one imaginary plus a real, or at least an imaginary number, because the real would be a 0. All right? All right, send me a picture of your FAIR model. Let's see what you wrote down. Bless you. Bless you. All right. So, I think we got it. Here goes the first part of the home plate. Look up to the screen. For the first part of the home plate tonight, they're going to ask you to show or to label which is which of that complex number. So, look up. Copy this one on your paper. Example 1, write 7 plus 3i. And let's do this one together. Look up. Here we go. you would circle this one. And instead of writing the word real number, I'm going to write this. Look up. The symbol for real number. Which means what, everyone? That the last part is our what? I for imaginary. Pretty straightforward, yes? All right. So, now that you have that, I'm going to send you to your screen another one, and I want you to label it for each part of your complex number. So, here goes the next one. 5 minus 2i. Don't write that on your paper. I want you on the screen to label what each part is for that complex. All right? Pretty good? Pretty straightforward, yes? All right, let's see. Monse, which is which? 5 is the real number, and negative 2i is our what? Imaginary. Yes. Hands, have you got that? All right. Here goes another one. Let me send it to your screen. Again, label the real number and label the imaginary number. All right, looks like Enrique's got this. All right, Enrique, what is the real number? 0. Hands, have you got that? All right, and of course the last portion is our I. Okay. And the last one, don't do that on the screen. Tell your neighbor the real number and the imaginary number for that one, please. Okay, we got it, yes? All right, so real number is 0, imaginary 7i. So for the first part of the home plate, how comfortable are you labeling our complex numbers? Yeah, we got this, okay. Shall we crank it up a little bit? All right, write this down, please. Example 2. Find the sum, difference, and product of 2x plus 5 and x minus 3. Find the sum, difference, and product of 2x plus 5 and x minus 3. Now, did I give you plenty of practice on the warm-ups? Yeah, so this is the second part of the home plate. I'll give you a head start. You should be able to do those by yourself, all 3 of them. Should be almost done. As soon as you're done, send me your answers to the screen. All right, let's see. Ashley, what'd you get for the sum? 3x plus 2. Hands if you got that. That is correct. How about difference? Pass someone. Caitlin, what'd you get? X plus 8. And remember for these, remember to distribute the negative in here. So that's negative x plus 3. Combine the 2x with the negative x. That's how we get x. 5 plus 3, that is 8. Hands if you got that by yourself. All right. Product. Pass someone. Who? Kelly, what'd you get? Negative. For the product? This one doesn't have i's, though. Two x squared minus 1x minus 15. Hands if you got that. That is correct. And once again, how do we get that? Distribute. 2x squared minus 6x. Distribute. 5x minus 15. Combine like terms. That's how we get this. And bring the other ones down. From 1 to 5, I'll comfortable argue with this. We got it, right? Plenty of practice on the warm-ups? Yes? All right. Give me a second. Send me your notes, please, for that. Are those the Chromebooks? Wait, are those cell phones? My goodness, bah. All right, so we're good with this, yes? All right, so let's move on. Yeah, let's do this one. Let's see how you do with that one. Example 2 super cube. We got ax plus c and bx plus c. Find me the sum difference in product. Let's see what you get for that. Go. All right. Check with the neighbors, see where they're at. Then Caesar, Jesus, and Sammy are going to enlighten us with the sum difference in product. All right. Caesar, what'd you get? You said AX plus BX plus 2C. Hands if you got that. That is correct. All right. So once again, AX plus BX plus 2C. Okay. Jesus, what'd you get for the difference? AX minus BX. And the C's cancel. Hands if you got that. That is correct. Let's go. All right, Sammy, walk us through the steps. AX times BX is ABX squared. AX times C. AXC. But I'm going to write it as, in alphabetical order, ACX. Next, C times BX, BCX, and C times C, C squared. Can we combine anything? No. And we are done. Let's go. All right. Let's move on. Send me that, please, as soon as you're done. Next one, example 3. Copy that one. It says find the sum difference in product of 5 plus 7i and negative 2 plus 9i. You should be able to do that one by yourself. Then we're going to have Sebastian, Rachel, and Gabriel enlighten us with those. I'll give you guys some time. Go. So, was it enough practice on the warm-ups to get you to this part? Yes, right? Okay, good. Let's go with the sum. Gabriel, what'd you get for the sum? 3 plus 14i. 3 plus 14. 16i. 16i. Hands if you got that. That is correct. How about difference? Rachel. Positive 7 and negative 2i. Hands if you got that. That is correct. Once again, don't forget to distribute the negative in here and here before you combine. Wait for the pass. And then you combine at the end. All right. Product. Sebastian, what'd you get? Negative 73 plus 31i. Let's double check. 5 times negative 2 is negative 10. 5 times 9i is 45i. 7i times negative 2 is negative 14i. And 7i times 9i is positive 63i squared. Combine like terms, negative 10. 45 minus 14, that's positive 31i. Then we have positive 63, but we multiply that by, what do we substitute for I squared, everyone? I squared is negative 1. So that gives us negative 63, and negative 10, that's negative 73. That is correct. Let's go, Sebastian. From 1 to 5, how comfortable are you with these? All right. Do we need one more, or are we good? We good? Let's see. Ashley, paper, rock, scissors. On 3. Ready? 1, 2, 3. 1, 2, 3. Let's go. Another one. Copy this one. No, we tied on the first, and then I won on the second. You did? Oh. Copy this one. Example, last one. Example 3Q. Negative 7, 3i, and negative 3 plus 2i. Let me send that to your screen. There it is. As soon as you're done, send me your work. What do you guys say, paper, rock, scissors, or rock, paper, scissors? Okay, what if I say paper, rock, scissors? I'm rigging it. I'm rigging the game. Be nice. All right, check with the neighbor, and then I'm going to have, how about Dana and Denise and Mayrim enlighten us with those answers. All right, for the sum, Dana, what'd you get? Negative 10 plus 3 plus 2, that's 5i. Hands, have you got that? That is correct. How about difference, Denise? Negative 4 plus 1i. Yeah, plus 1i. All right. Hands, have you got that? All right. And last but not least, product. What'd you get, Mayrim? 1 what? 21. 23i plus 6i squared. Okay. Let's see. Let's see. Yes. That's 14 and 9. That's 23. And then positive 6i squared. Okay, so far so good. What is our last step, Mayrim? Negative 1 times 6. So that is 21 minus 23i minus 6. Combine these. That's 15 minus 23i. Hands, if you got that? All right. And that's going to be pretty much the home plate for tonight. From 1 to 5, how comfortable are you with the first 2 parts? We're good, right? All right. So, with that said, here's where I get to the next part that I love. And do we have time for one more? Let's see. How does it look? Oh, big numbers. Rock, paper, scissors? Or paper, rock, scissors? All right. Looks like Sebastian's going to go on 3. Ready? 1, 2, 3. Ready? 1, 2, 3. No, let's move on. Here we go. All right. Writing utensils down, look up to the screen. Here goes a quick intro. Ready? What, Ashland? Am I cheating? What? Why? Why was I cheating? Oh, so I was like predicting what you guys were doing and then I left it? Okay. All right. Electric circuits. You guys seen this before, right? Look up. There's a switch, there's a battery, there's a light bulb. Yeah? Yes? 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 Okay. All right. So, how does that translate into diagrams? It looks like this. Battery, switch, lamp. Mr. Gill, why are you showing us this? Because you guys see these switches or actually use them every day. Look up. These are a little bit more complex switches. Have you seen that before? They're in your Chromebooks. They're in your cell phones. They're in your TVs. Here's some other ones. More switches. Same as what I showed you, but in a different presentation, and so on and so forth. So, and of course in your cell phones. Why am I showing you this? Because this is where we're going. We're going to be using complex numbers, but now with electronics. So copy that table, please, on your notes. Circuit component and symbol in circuit diagram. So we're going to be looking at 3 components. The first one is known as a resistor, and this is the symbol. The second one is known as an inductor. This is the symbol. And the third one is known as a capacitor. This is the symbol. Now, the resistor, look up, look at the symbol of the resistor. Have you guys seen that in light bulbs? Have you seen that in light bulbs? Whenever you have a chance, guys, those of you that have not experienced this, there's such a thing called a light bulb. If you go take it off from the ceiling right there in your room, I want you to look at it. Those that are clear, and you're going to see that is like a little tiny thin like wire that lights up when you put power to it. That's why we use that symbol for resistor. The second one is an inductor, and notice it looks kind of like a coil. Well, the way they make inductors is that they grab like a metal, and then they get a wire and they wind it a lot, and that creates an inductor. Now, a simple science experiment that you can do at home, get a nail, go to the garage, get a nail, get a wire, put it around it, those wires that are colored white or red or blue, then get a battery, and you just created a magnet when you put the battery to the wires, and then you can be picking up stuff with a magnet. That's an inductor. Capacitor, notice it's like a T sideways with another T, because a capacitor, look up, stops current from going in one direction, and it stops it like this. If the current is coming like that, it stops it. If it's coming like that, once again, it does what? Stops it. Look at the symbol. It makes like a little stop sign. You guys see that? Yeah? I mean, maybe it's not quite there, but, you know, close. Are we there? All right. So once again, resistor, inductor, capacitor. Yes? All right. So check this out. Copy that and label each part of that diagram. Label each part of the diagram. Once you're done, send that into the screen. All right, let's see. For the sake of time, Joseph, what do we call that? Resistor. I'm just going to write the letter R. That is correct. How about this one, Mariah? Inductor. That is correct. Which means, Camila, what is this one? Capacitor. That is correct. Now, the reason I'm giving you a simple one like this, oh, and by the way, right here, just label it voltage. Voltage. That's where the energy goes in through. Because tomorrow, it's not going to be as simple as this. It's going to look something like this. Ooh, let's go, Jesus. Let's go. All right, we'll stop right there. Log out of Nearpod, please. Once again, do your practice at home, do your home play, and don't forget your signed screenshots, please. Tell you never what I just said. Go to Canvas, take a screenshot, get it signed, bring it back tomorrow. Stop the video right there. See you guys tomorrow. Bye.